So today we will start our new chapter, which is work, power, and energy. But today we will only discuss about the work. Now, basically, what is work? Like you guys have studied about this in your previous classes as well. So, but now let's look into the introduction of this. So, work is basically the dot product of force and displacement that is basically known as your work. If you don't know what is work, go watch my videos on the vector chapter so you can easily make your concept regarding the dot product clear, and then come back and watch this video again. So basically the work is the dot product of a force and displacement, right? And if we talk about the formula for the work is F is equal to F dot D cos theta. Basically, sorry, here the formula is just F dot D, but as we know that the trigonometric function for the dot product is cos theta, so here we will put F is equal to F D cos theta, right? Now let's look into the unit of this work. Basically, we know the unit of force is Newton and the unit of displacement is meter. So the unit of work is Newton meter, which is denoted to a new unit which is known as joule, right? Even though energy has the same unit as well, which is the joule, right? Now let's talk like what is the difference between then work and energy. Like if they both have the same unit, same dimension, and what's the difference? Actually, the work is a way of transfer of energy. Work is basically way of transfer of energy, but it is a mechanical method. It is a mechanical method, but if you talk about the rest of the methods, they all are like other are non-mechanical methods, right? Now let's discuss about some factors in which the work basically depends, right? The factors involved in the work is the first, the force. If the force is equal to 0, then this work will also be 0. If we talk about displacement, must remember here we don't count distance, we count displacement, because there is a reason as well. I'll be telling you guys in this video. If displacement is 0, then the work will also be 0. Now the third thing is angle. Like if the angle is 0, then we know that cos 0 is equal to 1, so it means the work will be maximum. So when theta is equal to 0 means work is maximum. If theta is basically 60, then the work is basically half. If the theta is equal to 1, if theta is equal to 90, then the work is 0, right? If the theta is equal to 180, then this work is negative. Even though when the theta is equal to 270, the work is negative, right? These are some factors in which the work depends. Now let's discuss about the force, like which type of force is required in the work. So the force required in the work is like basically we have two types of forces. Number one is conservative force, right? And second is non-conservative force, right? Basic conservative force are basically they does not they do not depend on path, like they are independent of path, or you can say they do not depend on path, right? But if we talk about the non-conservative force, so basically it is dependent on path. It is dependent on path, right? Basically they're dependent on path, this non-conservative force. So basically if we talk about conservative force, here we include if you talk about example, here we have gravitational force, magnetic force, we have weak nuclear force, we have strong nuclear force. All the forces, like all the fields, like gravitational field, nuclear field, magnetic field, they all have the force involved, which is conservative, right? So if you talk about the work involved over here, so basically work is independent of path. Work is independent of path, right? For example, this is point A, this is point B. This is one way to go over here, to one another way, and this is another way. So the work that we will count during this will be from this one, because this is the shortest distance, and here we have the displacement, and these both are basically path, right? I hope this is clear to you. Then let's move towards the okay. If the work is done, if work is done against the gravitational field, that is known as gravitational potential energy, right? So consider that there's a ball and I have thrown this upward, so obviously there will be a gravity which will attract it, so this will be height. So the angle which will be made over here will be this 180 degree, right? If I want to make the if I want to take out the work over here, so we know that W is equal to W is equal to F d cos theta. So here F force will be basically weight, because weight will be attracting the body towards the center. So mg, d means this here height, and cos theta, instead of theta we will put 180, cos 180. We know that value of cos 180 is basically -1, so where W is equal to mgh minus 1, right? Now it will be equal to W is equal to minus mgh. This is the formula of gravitational potential energy. Gravitational potential energy, right? Now let's talk about some units of this work, right? Let's talk about units. So first unit we have, this is joule, which we have discussed as well. There's another unit in the CGS system which is BTU. So basically British thermal unit. 1 BTU is equal to 1055 joules, right? We have another unit which is known as electron volt. 1 EV, which is equal to 1.67 exponential power minus 19 joules, right? So over here this unit is basically used in the micro level energy, and this is used in macro level energy, right? We have other units as well, like calorie, joule, erg, right? We have calorie as well, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. Very glad to